Hello and welcome. Today we are diving headfirst into one of the biggest, most mind-bending mysteries in all of science, dark matter. You know, it's this invisible something that seems to be holding our entire universe together, but we have literally no idea what it is. So let's get into this cosmic detective story. All right, let's start with the big picture, right? What you're looking at here is basically everything, the whole cosmic pie. Dark energy, that's a whole other can of worms, makes up over 68%. But look at that other massive slice. Almost 27% is dark matter. And that little tiny sliver, that 5%, well, that's everything we can see, everything we can touch.
And this is where it gets really wild. That 5%, that is every single star, every galaxy you've seen in a telescope, every planet, every grain of sand on every beach, you, me, all of it. The other 95% of the cosmos, it's made of stuff that is completely invisible to us. It just goes to show we're living in a universe where the vast majority of what's out there is completely hidden from view.
So you have to ask, how in the world did we figure out that 95% of the universe was just missing? Well, it all started when astronomers noticed that galaxies were behaving really weirdly. This was the first clue in what's become the case of the missing mass.
Now this slide gets to the heart of the whole mystery. On the left, you see how a galaxy should spin, based on all the stars and gas we can actually see. You know, just like in our solar system, the stuff farther from the center should move slower. Simple physics. But on the right, that's what astronomers like the brilliant Vera Rubin actually saw. The stars on the outer edges are moving just as fast as the ones in the middle. Think about it like a merry-go-round spinning so fast that the horses on the outside should be flying off into space, but they aren't. Something invisible, something with a whole lot of gravity, has to be holding them in place.
And believe it or not, this isn't some newfangled idea. Way back in 1884, Lord Kelvin had a hunch that most stars out there might be dark bodies. Then, fast forward to the 1930s, an astrophysicist named Fritz Zwicky was studying a cluster of galaxies and realized they were moving way too fast to stay together. He calculated there must be 400 times more mass than he could see, and he called it Dunkelmaterie. German for, you guessed it, dark matter.
But those strangely spinning galaxies, that was just the beginning. That was just the first piece of the puzzle. Over the next few decades, the clues just kept piling up, coming in from all corners of the cosmos, and they all pointed to the same ghostly culprit.
What makes the case for dark matter so incredibly strong is that it's not just one thing. We have all these totally independent lines of evidence. We see its gravity bending the light from distant galaxies, a process called gravitational lensing. We see its fingerprints all over the faint afterglow of the Big Bang. It even acts as a sort of cosmic scaffolding that allows large-scale structures like galaxies to form in the first place. All of these clues point to the exact same conclusion. There's about 5 times more stuff out there than we can see.
Now, if there is one piece of evidence that physicists will point to as the absolute smoking gun, it's this, the bullet cluster. This isn't just a galaxy. This is what happens when 2 entire clusters of galaxies smash into each other at unbelievable speeds.
And this is exactly why it's the smoking gun. See, as these 2 clusters collided, all their hot gas, which is most of their normal visible matter, crashed together and slowed way down. But using that gravitational lensing trick to map where all the gravity actually is, astronomers found something incredible. Most of the mass, the source of all that extra gravity, didn't slow down at all. It just passed right through the collision like a ghost. This clear separation of mass from the visible matter is pretty much direct proof of some invisible substance that doesn't interact with anything except through gravity.
Okay, so the evidence is just overwhelming. Something invisible, something massive, is out there. So the next question for our cosmic detectives is pretty obvious. What is it? Let's take a look at the lineup of prime suspects. Right now, there are 3 main contenders. First up, you've got WIMPs. For a long time, these were the leading suspect, weakly interacting massive particles. Think of them as heavy ghosts that just float right through normal matter. Then there are axions. These are super lightweight particles that would act less like a particle and more like a giant invisible wave flowing through the cosmos. And finally, you have primordial black holes. These aren't your typical black holes from dead stars, but ancient tiny ones that could have been forged in the crazy heat of the Big Bang itself.
So, with a list of suspects in hand, the great hunt is on. All around the globe, scientists are running these unbelievably complex and sensitive experiments, all designed to finally catch one of these ghostly particles and solve this mystery for good.
To track down these suspects, scientists are basically using a three-pronged attack. First, they go deep. They build these incredibly sensitive detectors deep underground, shielded from all other cosmic noise, just waiting and hoping for a dark matter particle to bump into one of their atoms. Second, they look up. They use powerful telescopes to scan the skies for flashes of gamma rays that could be produced if two dark matter particles happen to smash into each other and annihilate. And third, they try to build it themselves, using giant particle smashers like the LHC to slam protons together, hoping to create dark matter right there in the lab.
And here's the massive twist in our story. After all that work, after decades of searching with bigger and better experiments, we have found absolutely nothing. Not a single confirmed bump in the night, no flashes of light from deep space, no missing energy in our colliders, nothing. For scientists, especially those who bet big on WIMPs, this is becoming a real problem. The theory said we should have found something by now. The silence from these experiments is just making the whole mystery even deeper.
Now, this total lack of discovery has pushed some scientists to ask a really radical question. What if we've got it all wrong? What if there's no missing matter at all? What if our understanding of gravity itself is what's broken?
This radical idea is called MOND, which stands for Modified Newtonian Dynamics. It basically suggests that over huge galactic distances, gravity is just a little bit stronger than Einstein's theories predict. If that were true, well, you wouldn't need any invisible matter to hold those fast-spinning galaxies together. The implication here is huge. It would mean we'd have to rewrite the laws of physics that have been the foundation of cosmology for over a century. Now, to be fair, MOND does a fantastic job of explaining why galaxies spin the way they do. But it has a really hard time with some of the other evidence, especially that smoking gun, the bullet cluster. Remember how the gravity and the visible matter were in two completely different places? That's almost impossible to explain by just tweaking the laws of gravity. So for most physicists today, dark matter is still the best horse to bet on.
And that's where we are now, just staring out into the vast cosmic dark. We've spent centuries getting an incredibly precise understanding of the 5% of the universe that makes up everything we've ever known, everything we are. The search for what's hiding in the other 95% is truly one of the greatest scientific quests of all time, and the answer, whatever it turns out to be, is guaranteed to change how we see our place in the cosmos forever. So, what do you think we'll find?